Today, we're going to continue working on our usable TypeScript class that will allow us to build the game Connect 4. Previously, in part 3, we added in the game logic for allowing a player to place a game piece into a column. We then added in logic to validate that the move was valid, and we started to add the logic for checking if the game was in the game over state. In this part of the series, we're going to go ahead and take a look at adding in the actual game logic for checking if a player is won by getting a Connect 4. If you've missed the previous videos, there'll be a link on the screen as well as down in the description down below to find those parts. For the code for this part of the series, there'll be a link on the video as well as down in the description. In order to know if a player has won the game after playing their last game piece, we will need to check for one of the 4 possible win conditions in the game of Connect 4. A player can win by placing 4 pieces in a row, a single column, or they can place them diagonally in a forward manner or backwards, so either a forward slash or a backward slash. For each of these win conditions, when a game piece is placed, we will need to check for the possible win segments that correspond to that game piece. So for example, if we place a game piece in the 3rd column, and the game piece landed on the 2nd from the top row, so here, we would need to check the following possible combinations for a win. So if we're going to check for our row, we need to check this combination, the next combination, and then finally this combination. Then for a column win, we would just need to check the pieces that are down below it. And then for our diagonals, we would need to go over and check this way, as well as down in these directions. For now, we won't go into detail on how we'll perform each of these checks, but instead we'll just create placeholder private methods in our Connect 4 class, and we'll cover each of these methods shortly. So to do this, let's go ahead and jump over to our code. Alright, so in our code, we'll want to go ahead and open up our source folder and open up the connect4.ts file. Then what we're going to do is we're going to create 4 new methods. So we'll have isHorizontalWin. Then we'll go ahead and pass in the last piece played row. And that's going to be a number. We'll have our minimum column be a number. Our max column also be a number. And then this is going to return a Boolean. So if the player won or not. And so for now, it's going to return false. So then we're going to go ahead and do isAVerticalWin. So we'll have a row and a column. We'll go ahead and return false for this as well. And then now we need to check our forward slash and our backward slash. So we'll do is /win. We'll have our row, column. We'll have our min column and our max row. So we're just going to copy this part here. And we're going to return false. And then we're just going to copy this statement. And we'll do is /win. So we'll have our row, column, and then we're going to have our max column and our max row. All right, so now that we have our new methods, we're going to go ahead and update our check for game in method to update our didPlayerWin variable here. So instead of just doing false, what we're going to do is we're going to call our new methods. So we'll do this.isHorizontalWin. We're going to go ahead and pass in our row, and we'll just pass in 0 for our other arguments for the time being. Then we're going to do or this.isVerticalWin, and we'll go ahead and pass in our row, our column, or if this is a /win, we'll do row, column, pass in zeros. And then finally, we're going to check if it's a backward slash win. So we'll do this dot is backward slash win, row, column, 0, 0. All right, so next we're going to go ahead and start adding in the logic for checking for each of these possible win conditions. So to check for a win in a column, we just need to take the location of where the last game piece was played and validate that the 3 game pieces below that one match the one piece that was just played. The reason we only need to check this one combination is due to how the game of Connect 4 is played. Since when we place a game piece, when we drop it into a column, we know the row the game piece lands in is the highest row in the column at that time. So in this example, when we drop this game piece, because there's already game pieces here, we know that this will be the highest row. There's no way possible for their pieces to be above it. Also, since we know that we require at least 4 game pieces in one column, if the game piece lands in one of the bottom 3 rows, like here, we automatically know that the player did not get a vertical win from the last game piece that was played. So we can go ahead and return early, and we don't need to attempt to check for all the pieces below it if it lands in one of these 3 rows. Alright, so to add this check, we'll come back to our code. Let's go ahead and go to our isVerticalWin method. Alright, so the first thing we'll do is we'll add in the logic for checking which row our game piece landed in. So if we know if the index is greater than 2, we can return early. Because we'll have 0, 1, 2, so if it lands in 3, 4, or 5, then we don't need to do our check. So we can do that just with simple if statements. We'll do if our row is greater than 2, we'll go ahead and return false. Otherwise, we'll need to go ahead and grab the cells of where our game piece landed, the ones below it. So we'll do const cells equals an array. We'll do this board, and we'll have our row, we'll have our column for our first element. For our second element, I'm going to go ahead and grab the next row down. So we'll do +1. So then we're just going to copy this and paste it 2 more times. And then we're going to go ahead and grab 2 away and then 3 away. So then what we want to do is we're going to want to check if all of these cells actually match. So we're going to do const isWin will equal this. And we're going to make a new method. So we're just going to call this do all cells match. And we'll go ahead and pass in our cells array. And then we'll pass in the element that we'll pass in the game piece that was last played. So we'll do this board. We'll do row, column. And then we're going to go ahead and return isWin. So then we're just going to go ahead and create this method. Do all cells match. And this is going to receive cells, which will be a number array. And it's going to receive a value, which will be a number. It's going to return a Boolean. So then, inside this method, what we'll want to do is we'll just want to make sure every single value in our array matches the game piece that was played. So we can do that by doing const isWin, and we're going to set this equal to cells. We're going to call the every method on our array. So this will iterate through our array, and it's going to make sure that the predicate that we provide always returns true. So what we'll do is for our cell that we're evaluating, we're going to check if, we'll do return our cell is equal to the value that we received in do all cells match. So our current game piece, and our cell does not equal 0. So we're just adding a safeguard here. That way, when we're doing our checks, that the cell is not an empty space. So it has to be a 1 or a 2, and it needs to equal our value. So then what we'll want to do is we're going to want to check who the actual winner is, and then update our game state to reflect that. So if this is a winning combination, so if isWin, we're going to check if the value is equal to 1. If it's equal to 1, then we know player 1 won the game. So we'll do this, game winner, and we'll do player.1. Otherwise, we know player 2 was the winner of our game. And we'll go ahead and return true. Otherwise, we return false. All right, so quickly to recap what we did here is in our vertical win method here, the first thing we did is we made sure that the row the game piece landed in is in one of the eligible rows we want to check. If it is, then we go ahead and we grab then we went ahead and grabbed the cells of the game board that we want to check. So where the game piece landed plus the 3 below it. And then we pass those to a new method. And all that method is doing is just making sure every value in those cells array that we provided matches the value of the last game piece that was played. So it's going to be a 1 or a 2. And then if all of that is true, then we know someone has won the game. And we're just going to go ahead and update our game state to reflect that. and then we'll go ahead and return true or false. To check for a win in a row, we will need to take the location where the last game piece was played and validate all of the possible winning combinations that can be made from that location. So as an example, in this image, if the player places a game piece into our third column, then we know we need to check the following combinations to see if there's 4 in a row since they all contain that third column. So we have our first, second, third, and fourth column, second, third, fourth, and fifth, and then our third, fourth, fifth, and sixth columns. So to figure out which combinations we need to check programmatically, we can use the column that the game piece was dropped into as our focal point. We know based on that position, the columns we will need to check will be within 3 columns, since we only care about 4 game pieces being in a row. So in this example, since we dropped the game piece into our third column, then we know that we only need to check for winning combinations that contain the columns 1 through 6. If the game piece was dropped into the fourth column instead of the third, then we would need to check for combinations that would be columns 1 through 7, so our whole game board. So one thing to keep in mind is when we're checking for these combinations, we're going to need to be able to keep track of where the edge of our board is, and we'll want to stay within that bounds. So to check for a win, we need to go up to 3 spaces away, both to the left and to the right. However, when we subtract 3 in this example, we know our edge of our board's here, so we wouldn't actually want to check -1, we'd actually want to check 0. Likewise, if we placed our game piece more to the right, we wouldn't want to go 3 away from the board. We'd want to stop at the edge of our board when we're checking our values. All right, so to perform this check, let's go to our isHorizontalWin code. This will go to our method. What we're going to want to do is we're going to go ahead and start at our main column that's provided, and we're going to go ahead and create a loop up to our max column, and we're going to check for the values of our column in that loop to see if all those cells match. So we're going to do for, we'll do let column equal our min column that we provided. And then we'll do if our column is less than or equal to our max column, then we'll go ahead and increment. So then we're going to do const cells equal to an array. And what we'll do is we're just going to copy this here. So we'll want to grab the cell of where our game piece was played. Actually, what we'll want to do is we'll copy this, and we're just going to do const row will equal our last piece placed row. Then what we'll want to do is increment our columns since we'll be checking to the right. So we're just going to copy this, paste this, and we'll go 1 column to the right. And then for our next 2 cells, let's go 2 and then 3. So we'll do 3 and then 2. So then we'll want to go ahead and just check do all cells match. So we're just going to copy this statement here. And then if is win, let's go ahead and return true. So next, what we need to do is actually update the arguments that's being passed into our method, our min column and our max column. So if we come back up to our code here, we're currently passing in zeros for these values. So to calculate our min column, what we're going to want to do is we're going to take our current column index that was provided when the game piece landed. We're going to subtract 3 from it. And we're going to compare this with 0, so the edge of our board, and we're going to take that max value. So then that way we always stay within the bounds. So to do this, we're just going to make a utility file to handle some of these functions. So we're just going to create a utils.ts file. In here, I'm just going to go ahead and export a function, and we'll do min, and we're going to do a num, we'll take it as our argument, do number, and we're just going to go ahead and return math.max, and we'll do our num -3, and we're going to go ahead and do 0. And then we'll just go ahead and copy this, and we'll also do our max while we're in here. So we'll do max. And so we'll take our number and we'll take our max value that we want to be up to. Number, and so we're going to do math.min. We'll have number +3, and then our max value. All right, and so what we did for our max function here, it's going to be similar functionality. We're just be checking the right edge of our board. So we're going to take our current column, and we're going to add 3 to our index value, and we're going to compare that with the maximum index of our board, which would be 6, and we only want to take the minimum value of those two. So what we'll do is we'll come back to our check for game end, and we're going to go ahead and calculate our min column and our max column. So we're just going to do const min column will equal min, and we're going to go ahead and pass in our column. Then we'll do const max column, and we're going to set this equal to max. And then we'll go ahead and do our column, and then we'll do our number of columns -1, so our index is correct. Then we're going to go ahead and update is our horizontal win, and we're going to go ahead and replace this with their 2 values. So we'll have our min column, and we'll have our max column. Oh, and so one thing to note is we use the static math.min and math.max methods to go ahead and get these 2 values. So math.max, what it'll do is you can provide it 2 values, and it will return whichever those 2 values is greater. Math.min, on the other hand, you can provide 2 values, and it'll give you whichever value is lower. All right, and so with that, we have our logic in place for checking for horizontal win, and now we can go ahead and start taking a looking at the logic for diagonal win. So similar to the logic that we use for checking for horizontal win, we can use similar logic for checking for a diagonal /win. So we're going to use the location of where our last game piece landed, and we're going to use that as our focal point. So from our focal point, we will know the positions that we need to check will be within 3 columns and 3 rows of our focal point. So as an example, in this image, if we place our game piece in our 3rd column, and it landed in the 2nd row from the bottom, then we need to only check 2 combinations for this possibility. So we'd have this one here, and then this one here. And so, to figure out which of these combinations we need to check, we will need to start at the bottom location of where the game piece is placed and count up to 3 spaces away, moving 1 column to the left and 1 column down, like this. The location we land in will be the starting location of the combinations that we need to check. So we will start from this location and compare that value with the next 3 cells in our diagonal. If the combination is not a win, we will move up to the next one, and we'll check those 3 cells, and so on and so forth until we complete our sequence. And so one thing to note is we'll continue to do this until we get to a point where we do not have 4 cells in our sequence because we are too close to the edge of the game board. So now, in order to figure out how far away the starting location is, we need to know how far away the current game piece location is from the edge of the game board. So as an example here, we can see that our game piece location, we are 2 columns from the left edge here, and we are only 1 row away from the bottom edge of the board. So due to this, we know our starting location for our combination check will only be 1 as a max location away, because we can only go over to the left 1 and down 1. Versus if we started up here, we can go over 1, down 1, over 1, down 1. So it'd be up to 2. So to get started, what we'll do is we'll jump over to our code. And the first thing we're going to do is we're going to go ahead and add in a variable for our maximum row. So we're going to do const max row, and we're going to go ahead and set this equal to our max. And we'll do the row of where the game piece landed, and we're going to take the number of our rows, and we're going to go ahead and subtract 1. So then what we'll do is we're going to go ahead and update our is/win to go ahead and take these values. So just go ahead and column, and then we'll have our min column, and then we'll go ahead and have our max row. So then what we'll do is we'll come down to our is/win method, and this should actually be max row as well. Okay. So the first thing we're going to do is we need to calculate the maximum number of diagonal spaces that we can actually check. So this is how far away from the border of our game board we are from our game piece. And so to do that, we're going to add a new variable. We're going to do let max diagonal spaces equal math.min. And so we're going to take the column of where our game piece landed, and we're going to subtract the minimum column. And then we're going to take our max row, and we'll go ahead and subtract our row. And so what this is going to do is going to return a value, which is the number of diagonal spaces we can go down to start our initial check. So in the one example, when we were 2 columns away from the edge of the left edge of the board, but we're only 1 row away from the bottom, this would ensure we only check up to only 1 diagonal space down instead of going to 2. So then, now that we know the max number of diagonal spaces we can check, we're just going to do a while loop, and we'll do max diagonal spaces. If it's greater than or equal to 0, then we need to keep checking sequences. And then at the bottom of our while loop, let's go ahead and decrement this. So we'll do max diagonal spaces, minus, minus. And so we're just going to loop through this so we can check all of our sequences. So then what we'll want to do in our while loop is we're going to get the current cell that we're checking. So we're going to make 2 variables. We'll do const temp column will equal our column of our game piece originally landed, and we're going to take our max diagonal spaces. Then we'll do const, and we'll do our temp row, and we'll set this equal to our row plus our max diagonal spaces. So then we're just going to add a safeguard. So if our temp row is greater than 2, and our temp column is less than or equal to 3, then we know we'll at least have 4 cells we can check. So for our cells, we're just going to do const cells will be equal to an array. And we'll do this board, and we'll do our temp row, followed by our temp column. And then we're just going to go ahead and copy this. And because we're moving up for our rows, we're going to go ahead and subtract 1. And for our columns, since we're moving to the right, we'll add 1 as well. So then we're just going to copy this, paste it twice, and we'll change our values. So now we'll have 2, we'll have 3, and then likewise 2, and then 3. So then what we want to do is we just want to check for a win. So we're just going to go ahead and copy this logic here. Paste that inside here. And only if we win do we want to return early. We'll return true. Then that way we can keep checking all of our sequences until we win. All right, so to recap what we did here, the first thing we wanted to do is we calculate our max diagonal spaces. And we just use this for determining the possible combinations that we can check. So to find this value, what we're doing is we're taking our current position of where the game piece landed, and we're finding the maximum row and the minimum column values that we can compare for these values. And so from this example here, if you remember, we are 2 columns away from the edge of our board, but we're only 1 row away from the bottom of our board. And so by taking the max row value that we can use in this combination check and comparing that to the minimum column, we know, and we take that difference, we can only go 1 away. We can't actually do 2, otherwise we're outside our board. So once we know the number of cells down that we need to start our initial check from, then we can go ahead and calculate that position. And so that's what we did with our temp column here. So we took our column and our row, we subtracted that value to figure out where our starting position is. We then went ahead and started our combination checks by doing this through our while loop. And so we took that starting position and we went ahead and just added 1 to our column and our row to find the next cells in the combination that we needed to check. All right, so the last piece of game logic that we want to add for checking for a win is we need to add in logic for checking for a diagonal win in the other direction. For the most part, this logic is going to be very similar to the logic we added for the / diagonal win check. The main difference is when we go to check our starting location for our win, we're going to move in the right direction. So as in the example here, if we placed our game piece in the 4th column, and we landed in the 3rd row from the top, we would want to move 1 column to the right and 1 row down, and we'll do this 3 times. So before we were going downwards in the left direction, now we're going downwards in the right direction. And so you see here if we place that game piece here, these would be our possible winning combinations based on where that piece landed. So similarly, we just want to do this 3 times until we reach the edge of our board, either the bottom edge or the rightmost edge. And once we determine that lowest location for our game piece, for our minimum column and row, we're going to go ahead and start from there and work our way to the left and up until we get to back to where we originally placed our game piece. And so we'll just have a check for the 4 game pieces in that sequence. So to go ahead and add in this check, what we're going to go ahead and do is we're going to go ahead and go into our is_win method, and we'll go ahead and just add in some of our code. So we're going to go ahead and copy our code from our is_win. So we're just going to go ahead and grab this block here and paste that here. And so what we're going to do is we're going to do our max diagonal spaces. We're going to do math.min, and we're going to do our max column minus our column index of where our game piece landed. And we'll do our max row minus our row. And so this will help us determine how close we are to the edge of the board, either to the bottom or to the right. Then we'll go ahead and do our while loop just like before. So we'll have our temp column, but instead of subtracting, we're going to go ahead and add, since we want to go to the right. And then for our row, we're going to go ahead and add so that we go down. And then for our temp row, we'll still have our check if it's less than 2. And for our temp column, if it's greater than or equal to 3, then we'll want to do this check. So then for the cells that we want to check, instead of incrementing here, we're going to go ahead and go down. So we'll do minus and then minus. And so the reason for that is we're moving to the left in the upwards direction. So we're going to want to go ahead and subtract to get those values. So then we'll just go ahead and check for our win. We'll return our win and we'll return true if it's true. Otherwise, we'll go ahead and iterate through our while loop until we get to 0. So with this last piece of game logic, we now have all the logic for checking if a player has won the game in place. So the next thing we're going to do is we're going to go ahead and update our test to go ahead and test this new functionality. And we're going to go ahead and add new tests for the following things. We're going to want to check if a player has won the game when the first player gets a Connect 4. We're going to want to check if player 2's won the game if they got a Connect 4. We're going to go ahead and check if the game ends in a tie if no players have won the game after the main board has been filled. And then finally, we'll want to check for different win variations using each of the possible win methods. So the vertical, horizontal, forward, and backward diagonal wins. So instead of typing all this code out by hand, there will be a link in the description of the video as well on the screen now to a gist that will contain the test that we'll be adding. So at a high level, our tests are going to match what I just described. So we'll have our simple game over test. We'll check for our vertical wins, horizontal, forward, and backward slash. So go ahead and click on that link. You'll get a copy of this code here. And then what we'll do is we're just going to copy that code. And we're going to go ahead and paste that into our test connect 4 test file. And we'll just add that at the bottom below our other test, but above our init methods. Then for our new test, what we're going to want to do is we're going to go ahead and call those methods. So I'm just going to go ahead and come back up, and we're just going to copy these function names and paste them at the bottom. So I've set up game over. I've set up vertical win test, set up horizontal test. Let's set up /win test. And then we'll have set up /win test. Let's go ahead and fix our functions. We'll go ahead and save. So there's a few things in our test that we're going to have to update. So we're referencing some code that does not exist yet. So what we're going to do is we're going to come to the top of our file, and we'll go ahead and explain this in a second. But what we're going to do is we're going to add a new type. So we're just going to call this type, call it data. We're going to set this to an object, and we'll have moves as a property. And this is going to be set to a number. Be an array. We'll have board state. This is going to be equal to our cell range. Be a 2D array. We'll have winner. This will be set to a player. And then we're going to have winning cells, which will be equal to our coordinate array. All right, so if we go ahead and save, our file should go ahead and compile now. And then what we're going to do is we're going to go ahead and try running our test. All right, so we'll go ahead and open our terminal. We're going to go ahead and run yarn test. And this should run our new test files. Oh, and it looks like we have a few bugs. So we're going to go ahead and come up to our test. They're all in our /wins. Yes. So if we go ahead and come back to our code, let's go ahead and come up to our check for win method, check for game end, and we need to go ahead and replace those zeros that we had hard coded. So we're going to go ahead and pass in our max column and then our max row. Let's go ahead and get rid of our to do since we finished our code, and we'll go ahead and save, come back to our test file. We're going to go ahead and rerun our test, and everything should pass. Perfect. All right, and so at a high level, we're going to go ahead and take a quick look at a few of our tests just to see an example of what we added. So for each of our wins, we went ahead and added our new suite with new test files for what we're testing. We've added an example of what the game board will look like after the moves have been made. And then what we did is we created a new data type called data, and this just holds some of the board state information, so that way we can easily reference it throughout our test file here. So as an example, we added moves. So this is the moves, so the indexes of when players place tokens on the board, and it's going to happen in this sequence. So if we take a look at our board, we'd start here. So 3, and then we go to 4, 5, 6, 3, 4, 5, 6. And so you'll see player 1, 2, player 1, player 2, and it just kind of repeats until this moves array is finished. So then our board state will match this comment up here. So this should be what we're expecting after all the players have placed their tokens. Then we go ahead and check for who the winner is. So based on our board state, we would expect player 1 to win because they have this // here. And then we expect this winning cell combination to make up that win. And so for that data type, what we do is we just run through our moves to update our board state, and then we just validate our board state like we were doing before. So all of our tests follow that format there, so we won't go through each one in detail, but that's them at a high level. All right, with that brings this video to an end. And in the last part of our series, what we're going to do is we're going to add some game logic to allow us to return the winning game cells. And we're going to go ahead and do some minor code refactoring by moving all of our type definitions into a brand new file. So as always, thank you so much for watching. I hope you enjoyed the content. As a reminder, in the description of the video, there'll be a link to the completed source code. If you're interested in more great content, please check out some of the links that are on your screen now.